Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Resonating structures, resonance structures, are different representations of the same molecule that differ only in the distribution of electrons, not in the connectivity, bonding framework of atoms. The positions of atoms must remain the same in all resonance structures. Moving on to the next step. Analyze option A. CH3N is equal to C is equal to S, methyl isothianate, and CH3SCN, methyl thiocyanate. In the first structure, the connectivity is CH3 attached to N, which is attached to C, which is attached to S. In the second structure, the connectivity is CH3 attached to S, which is attached to C, which is attached to N. The atom connectivity has changed. In one structure, N is directly bonded to CH3, while in the other S is directly bonded to CH3. This means the positions of atoms have changed, so these are not resonance structures of each other, they are structural isomers, constitutional isomers, specifically functional group isomers. Moving on to the next step. Analyze option B. CH3C plus is equal to O and CH3CO plus differ only in electron distribution, double bond versus triple bond between C and O, with charge relocation. The atomic connectivity, CH3CO, is the same. These are valid resonance structures. And for the final step, analyze option C. CH3C is equal to O, or acetic acid, and CH3CO is equal to O plus H differ only in electron distribution. The connectivity CH3COH remains the same with charge delocalization. These are valid resonance structures. Analyze option D. CH2 is equal to CH, CN and CH2 plus CH is equal to C is equal to N differ only in electron distribution through conjugation. The connectivity CH2CH-CN is the same throughout. These are valid resonance structures. Conclusion. Only option A has structures where the atomic connectivity differs, N bonded to CH3 versus S bonded to CH3, making them structural isomers, not resonance structures. Why other options fail? Options B, C, and D all maintain the same atomic connectivity and differ only in electron pair distribution, satisfying the requirement for resonance structures. Therefore, the correct answer is A. Therefore, the correct answer is option A.